literally like if you choose a pixel for both on the optimized scores, those are the scores it gives.
Okay.
It is.
That's part of the, yeah. That's
It is. It's essentially. It's the Igor Magic version of in-market marker pitch scores. It is using a log odds. I looked at the formula. It's not precisely log odds, but it's roughly the same idea.
Yeah.
There's there's a random number in there. I'm like, Igor, what's this? And he's like, magic to make it work. Okay. But it runs a whole lot faster than in market.
Yeah.
So it's roughly, I mean, and it generally gives you back reasonable things.
And its accuracy is far less sensitive.
Okay.
I wouldn't need, and if once you scored a.
Is that actually recording?
Yes.
Okay.
Well, it's also on the
Maybe.
Should I restart it?
No. I was just like writing out, like,
That's
just setting up.
That glare is pretty awful, though. There we go.
So yeah.
Can you still?
I can still see it.
Yep.
And we're probably school
Yeah, but then there's a glare like right across the.
It's like you've given classes before.
No, this is how it's gonna be.
Okay, fine, whatever.
There's like a glare right across the middle.
Yeah, otherwise it just doesn't work.
Otherwise you'll do it.
But the precision of it.
Okay,
And
so
it finds the right size. It does a really good job. Anyway, Marius.
okay, cool. That's clear, right?
It is now.
So this is going to be a quick talk about the general design of Git and how it functions. So Git is a distributed version control system, and it has a lot of similar concepts to how Perforce works, but due to the distributed nature of it, some things simply don't make sense. Because in the traditional Git approach, you don't necessarily need a canonical sort of source repository that has all the stuff. So your local repository, in fact, contains the complete history of the code that you have. And you can pick that thing up and move it anywhere else. And you don't actually need like the central Bitbucket repository at all to function. Which is useful because that means that we can all work largely independently and then push things back up to it, and it'll be fine. So the general design of Git is you have a remote repository, which in our case is the Bitbucket repository, and that's where that's sort of the canonical source of truth, where the code lives, where the build service will pull from, and where you ultimately push your code to. You have a local repository. This is something you've cloned from the remote, and this doesn't look like a normal file system. Inside your repository, there will be a folder called .git inside every repository that you clone. That is this thing. This contains the entire history of everything, as well as sort of some branch information of where branches are, where other branches in this thing are, so that you have like references to what branches are, and you can manipulate this one from your working copy.
Is that only local, or does it? Sorry, you said it keeps track of some stuff on the remote, but I'm guessing you have to sync it.
You have to fetch. So you have to fetch. So there's a couple of ways. So if you want to pull things from the remote into local, so this is a fetch. And a clone. That's how you get from here to that. That's a git fetch or a git clone. So the first thing you will typically need is, we care about our files, which is, the working copy that you've checked out from here. So from here, you can check out your code. And this will actually make you, a directory that has the files in it that you expect. Which, is ultimately what you're going going to modify. This is basically just the standard folders with all your files. Unlike Perforce, it doesn't do bullshit things like mock them all read only because we're all adults here. And also, it doesn't really matter. So and if you change a file in here, nothing happens automatically. So Git is very explicit about how things move between these phases. So if you've now made some changes to a file or made a new file and you want to push it all the way back, there's an approach to how you do this. So you add a file or files to the index. So the index is a thing that sits sort of in between the local repository and your working copy. And that's it's a staging area where you place files before you commit them. In general, for a lot of simple workflows, you can largely ignore the index because you're just going to sort of add files and then you're going to commit them and they go to the local repo. But the index is very useful if you want to do sort of more advanced things, or if you want to sort of specially craft your commits out of sort of hunks of files that you've changed. You don't want to commit all of it. You want to commit like a little bit. You can definitely you can do all of that. So essentially, what happens is when you add a file that you've changed, it makes a copy of that file at that point in time and places it in the index. If you now go and change that file later on, and then it commits the one that you've added to the index, not the thing that you've changed, unlike Perforce. So in Perforce, when you add a file to a change list, it just adds that file, and if you change it, you commit the changed file. Git does not work that way, and that has several sort of useful features, so that you can sort of more systematically build up your commits if you have something sort of large you want to build. Then from the index, you commit. And that will actually go and create a new commit in your local repository. That has not actually been synced to the remote yet. You have to explicitly go do that. So you can build up a whole bunch of commits, and when you're sort of happy with the work that you've done, then you push. And once it's pushed, it's in the remote repository, and other users can get it. So you can do a lot of work on your local without actually needing to touch the remote repository at all. So this sort of model is useful to think of when in terms of like what actually happens when you get files and you change them and so forth, is they move through these stages always. There's always the notion like you can never really break this thing. I mean, aside from deleting random files in the .git folder, and don't do that. But it's hidden, and you really shouldn't be touching that in it. So you can't mess this thing up particularly heavily. And if all else fails, if you completely screw it up, you can always just destroy it and clone another one from your remote, which is there's an XKCD reference for that. So the other key difference is Git has extensive and really good support for branching because your commits are a directed acyclic graph, essentially. So, well, not essentially, they are, and you can do all kinds of sort of interesting graph manipulation things to it, where you can take a bunch of nodes and reattach them out, somewhere else. That will generally mean you will have conflicts and you will have to resolve them. You can do it. You typically shouldn't, though, just because if you change, so in Git, your history history in your local repository is actually mutable. So you could go and change old commits. But that doesn't actually change the commit, it just makes a new commit that is different. And all subsequent commits are also now different, even if they have the same content.
So Marius, at what stage do we worry about merging? Do we still merge at the commit stage?
So merging. So merging is so if you've got, let's say we have some commits, right? This is branch A and this is branch B, right? So you're working on branch B, and you commit onto this thing. So if I've changed the same file, the same hunk of the same file in these two commits, and I want to merge this guy back in, then Git will tell you that there is a conflict. It'll throw up a dev tool, and you'll have to go resolve that conflict.
Okay, so
if you didn't change the same hunks of the same files, then it'll basically just do it'll do like what's called a fast forward merge, and then it's just like it will just connect that thing without actually that node containing any code whatsoever.
Are A and B two local branches in this case that we
Yes.
out? Okay.
You always operate on local branches.
Okay.
In fact, you cannot operate on non-local branches.
Can you maybe explain just a little bit about how branches fit into this remote local index?
Yes. So your index contains a reference to the head, which is basically it's a pointer to the commit that to the most recent commit that you're on. So when you change branches, what actually happens is this pointer, which is itself actually just a file inside the Git structure, changes to instead say to reference this hash rather than this hash. And that's essentially how. So when you do a checkout of a different branch, what it does is it changes your working copy. It sets your head pointer to be in that different branch, and it doesn't do anything to this guy because it doesn't need to. When you now commit, so inside your local repo, you have a list of pointers that are branch pointers. So you'll have a pointer that is called A, that references this guy. And when you do a commit onto branch A, it'll move this guy up and say you are now here. And that's so in terms of like how branches work in that setup, it's really just moving a reference around in this tree structure. So you basically just say, I have an active node in my tree, which is which in Git terms is a commit. So you have like a commit that is your current node in the graph that you're operating in. And all actions you take, like commits and so forth, are children of that current node. And as a result, so you can be on this guy, make a commit, go to A, go back, make a commit, go somewhere else. Which is useful if which is a very standard case if you have the situation where this commit is both your feature branch A and master. Right, so you'll make a commit onto A, you'll decide I'm not done with it, but I have to start working on like feature branch B, for example. So then you can just go back to master, create a new branch B, so check it out, which all that checking out at that point will do is it'll just change that head pointer, and then you can start adding commits to it and sort of start writing there. So the branch model is relatively intuitive, and you should probably not worry too much about exactly how it works. It's mostly, it pretty much works the way you'd expect it. If you're on a branch and you commit things, it commits to that branch. If you merge, you merge into that branch. So if you want to merge things into master from B, you have to check out, go into master, and merge B into it. Because you want to change master, not B. So
how do you determine which point A is going to? Because now A has two routes, right?
no,
So how?
A only has A refers to just one commit. So
Right, but you said A can go to somewhere else.
well, you can always move this guy somewhere else, but it's only ever in one spot.
So what do you mean by somewhere else?
So I
Which
can
means
just,
you're making changes to different files.
yeah, it's like A is just a name, right? I can just take that away and say A is out here. There's nothing stopping me from doing that. If I do that in this case, though, this thing doesn't actually have a name attached to it anymore, and Git will detect this and warn you about it and say you have like dangling commits that are unreferenced, and it will clean these up after a while.
And by saying merge, you mean so A is making the same file that B is making change to, right?
So Git does not operate on files. So Git operates on trees at a time. Unlike Perforce, which versions files individually, a Git commit is your entire tree inside that repository. So all the changes to all the files that you made is one commit. So this checkout here, if you haven't changed it, is the state of the repo at a given commit.
So my question is, how do you determine you're going to merge?
Well, if you're in this situation, right? If you have, B and A, right? So you determine if you're going to merge by deciding you want to merge, right? So you have to. It doesn't happen automatically.
In that example, master A right there, that final node on master,
Yes.
that is what's in production right now.
Yes.
Okay, and so I've just written some code on that branch.
You've written some code on that branch. You're happy with it.
and now I want
It
it
passes
part of-
tests and all of that jazz, and now you decide, okay, we're happy with this. So in the Bitbucket approach, the way we want to do this for sort of large hunks of code is from this guy, you will push B to the remote, and you'll create a pull request. That references B and asks it to merge this guy into master. Somebody other than you, preferably, should review that pull request and accept it. And if they don't like the code, they should tell you what's wrong with it. Right? And that will perform the merge. You can do this yourself. So if you have if you have repositories that are relatively small that only you are really going to work on. So for example, a lot of the analytics sort of scheduler jobs and things like that. Odds are you're probably going to be the only person. It's you're not really going to trample over other people when you do this. In general, you should not be pushing code into master explicitly yourself. It is dangerous, and bad things will happen. Especially in the case where you have multiple developers working on the same code base, sort of simultaneously. Then if everybody pushes into master, what you end up with is something that looks like this all the time. You have like a whole bunch of branches, and it becomes like fairly confusing. It'll still probably work, but you may have to deal with a lot more sort of conflict resolution.
So then, what do you push into?
So typically, what you want to do is you don't want to work on master. You want to make yourself a feature branch, call it whatever the hell you like.
Oh, yeah.
It doesn't matter, and you do your work on a feature branch and you push that feature branch. Because odds are not that many. You're not that feature branch isn't being worked by many people.
And you create that feature branch at the checkout phase for local reload and local company.
So basically, you will check out master, and then you say git branch right feature. That will make you a branch called feature, and then you at the commit at the head where you're currently at, and then you can check it out.
But how do I keep my feature branch up to date with changes in master? People make changes in
Sure.
master.
So what you do there is you check out your feature branch.
Yeah.
You pull from master. You merge master into your feature branch.
So you can fetch it again, and
Yeah.
it'll just give you new master, and you can say merge,
Yes.
all in your local.
Yes.
And now you've merged, you have the latest update plus your work.
Yes.
So you're merging between local and work.
Yeah. So you could have the situation where you've decided before you want to do this pull request here, right? You said like, well, let me just make sure that everything's okay, and then you'll do this, right? So you're still on B now, and you've merged master into B.
But that line only exists on your local. That line doesn't actually exist in remote.
Until you push.
Okay, and then, okay.
Until you push, that line will exist on the remote,
Okay.
because the graph topology requires that it does.
Okay.
But commits on master will carry on that way, right?
Until you merge.
Until you pull that guy back out. So for long running branches, it's very common to merge master into your feature branch regularly. But you can be quite far off, and it's still probably okay. The advantage of merging master into it regularly is that the chance of conflicts is obviously minimized.
Is there a best practice around like when to push your feature branch up to remote? Like, should you wait till until you've got a steady set of commits that you're pretty sure you want to
pushing your feature branch up to remote, you should do that often.
Okay.
Because your local repository is not backed up.
Right. Okay.
The remote is. So
That makes sense.
And it's not messing with
If you're-
production at all,
it's
right?
not messing
Right.
with production at all because you're not pushing the master.
Right.
Right.
So it's a completely
So-
separate branch.
So that's one of the other key things is that it's like our builds will typically run off of master or like maybe some other sacrosanct develop branch or something. But they will not be running off your feature branch.
Right.
We will probably. I don't think if we've set this up yet, but we will set up things where if you make a pull request, it'll initialize the pull, so that it can sort of see if you've passed unit tests and all of that stuff. And if you don't, you'd like to know about that before you merge it in,
Yeah.
which is just kind of obvious.
Okay, so a somewhat different question, but I'm not quite sure how it fits into this whole structure. So, like Boson, we have the main stack of Boson, then we are rewriting all the Boson code.
Yes.
Or there's retargeting, and they're rewriting the retargeting model.
Yes.
So you want the current one, but now you want this other version that you can push to remote so that everybody can see, like Walt and
Yeah.
Ulrich, Yorick are working off of the same
Yes.
stuff. So is that just like an entirely different repository?
No,
with
no,
new
that-
stuff, or
so-
how is that working?
So the thing is inside this remote, you can have multiple branches.
Okay.
There's nothing, and in fact, you will have multiple branches. So all that differs in
So
that
branching
case.
is not just in your work.
No. Branching is everywhere. So in that case, what you'd have is you'd have a develop branch inside your boson repository, and instead of basically saying that your feature branch has to merge into master, you'd probably ask somebody to merge your feature branch into develop.
Okay.
And then eventually, when you're happy with all the stuff that's in develop, you pull that into master again. So, you can create your feature branches off of anything, including your other feature branches, right? They're just, it's just a graph, where you split your graph.
So when you create a branch out remote, you still just check out master.
Yeah.
Pull down, create your branch, call it dev.
Yes.
Push it back up.
You have to push the branch dev back to the remote. Now there will be a branch called dev on the remote.
And then now other people can fetch or clone remote.
Yes.
Your remote dev branch.
Yeah.
Do the remote dev branch. People can then clone that branch.
Yes.
Do their work, create another branch.
Yes.
Merge that back into dev.
Yes.
So another example is maybe simple, but Boson's a good example. We went from one giant file to refactoring a bunch of small files. How would that work in this situation?
You would create a bunch of small files.
Okay, so it'd be still on the same branch. It's still
Yeah.
branch. So it can hold multiple files.
Each branch and node is not a file.
Okay, it's
Yeah.
it's okay. Got it.
So each commit is the whole tree.
Like a state
Okay,
of the,
got it.
yeah.
It's the state of your repository.
Got it. So it doesn't have. It's not a one file of code. It can be.
In fact, each commit is the full contents of every file that changed,
Got
not just the diff.
it. Got
Like the whole file is the commit. So every file in the tree that has changed is part of your commit.
Got
Which is useful when it comes to the index, because when you add it, you add the whole file to the index. And then you can very easily, if you make changes to it later, you have the state where you have some uncommitted bits of that file and you have some unstaged bits and some staged bits. And you can decide to commit only the staged bits. There's also some stuff that I'm going to be looking into in terms of exactly what is a nice practice to version control notebooks. There are some relatively easy things you can do to strip output of notebooks. But it's like you probably want to turn that on a case-by-case basis. But you can definitely do that where you strip where instead of committing the notebook with all of its charts and figures, you probably don't care about that much. Then you can just strip all the output before you commit it, so automatically.
Do you have any other recommendations in this area?
Any other questions? I didn't go into how the commands work, but it's there are substantially better guides about that, and I'll share with you guys a nice sort of tutorial page that I found that explains the commands with this backing behind them, so that you can see how these things affect the various phases, which is useful. There are loads of good easy Git tutorials online. It turns out if it's the version control system that basically everybody in the world uses, turns out lots of people have written tutorials for it. The tutorials that git-sem.org are super complete, but also really long. Because they're a lot better these days because they're no longer just the man pages, which they used to be. But it's all of these commands have a bajillion potential arguments you could give it to them. But generally, you don't need to care. Especially a lot of you people will likely be using some visual tools like SourceTree. SourceTree integrates very nicely into Bitbucket server, So it's like if you set up your credentials, it actually has a remote repository browser, so that you can see what all the remote repositories that you have access to are. You can find them very easily, which is sort of very useful. There's a bunch of them. So if you don't like substring for whatever reason, there are many. It's like, I don't like sorcery, so I won't be using it. But I do know how it works. I started using Git like 9 years ago, so the tools I like are the tools that are 9 years old. Oddly enough, it's like generally I like new tools, but it turns out like the really, really old tools that ship with like Git from the beginning, they're still good. And they're also unchanged. They're exactly the same as they were 9 years ago.
Do we have Git bash on all our analytics servers and stuff?
I doubt we do. But so if you install sorcery, I think you get Git bash already. I think it will come with it because I mean it's like you need the MintGW, well MSys, you need MSys Git on your machine for the stuff to function. Pretty much everything bundles the same thing. So they'll all basically ship with an instance of MSys Git, which includes Git bash. So if you want to just use the command line, you can definitely do that. All of the tools are originally written with a command line in mind. So the other thing is Git is installed on like pretty much all of on like Interest 2 and all of those boxes as well. So it's fairly easy for you to clone the Bitbucket repo into Interest 2, make changes to it there. If the changes to it there are say I change a notebook, you could very easily sort of initialize your notebooks folder as a Git repo. It's like add your notebooks to it, push those up to Bitbucket, whenever you want. Which may be a useful thing to do if you want to sort of version control your notebooks.
Is there anything to know about the relationship between projects and repos? Is that just a thing for Bitbucket?
So in Bitbucket, projects are sort of the small little acronyms. So like analytics is acronym is like AN, and there's an analytics scheduler job, which is ANSJ, and then there's like an analytics personal, which is I think ANP. Those are just really collections of things. So a project contains a bunch of repositories under it.
It doesn't really change this.
It doesn't change this in any way. It's just a labeling and a grouping.
Like schema.
Yeah.
Permissions.
Yeah. It's a schema with permissions, right? It fulfills exactly the same role as like a user in GitHub. So a user has multiple repositories. You can really just view those projects as users that have repositories. Except in this case, it's not a user, but a group of users. That's just
Probably
been given a name.
compliance easier. So not everyone can see everything.
Yeah, you can't see all the repos. It's like there are, if you have like weird issues with your Git repositories on Bitbucket, that's probably me. So if you have
Yes,
weird,
10 minutes over.
what? So if you
I'll
have
write
weird,
it up.
yeah, if you have weird issues with your GitHub or with your Bitbucket repositories on the remote, me, Josh, and Mark are administrators of those. So you can come and talk to us. If you have really, really, really weird issues, you go talk to Taylor. But hopefully, you won't. Those won't be that necessary. But in terms of things of like, how do I migrate my goals on like the build server to use Bitbucket rather than Perforce, you should definitely go talk to Taylor. I haven't done that yet for my stuff either. But we will.
Taylor's supposed to be taking care of that for people who told me that there was bills
Yeah.
associated with the projects. And
So all that's happening right now for those is there's a sync back to Perforce.
Yeah.
Which we should go and get rid of because we don't need it. We just make the bold views get like it will in the future. Cool.
Thanks, Marius. Thank you, Marius.
I now need to go wash my hands. I don't know. It's the side effect of these
We
things, right?
stop this.
It's punishment for making mistakes.
Hey, Mitchell.
Mitchell.
It's